Mercury and Venus. Two hostile worlds that suffered very different fates. One, very much alive and seething with treacherous forces of nature. The other, a planetary carcass, gouged by millions of high-velocity impacts. Both demonstrate the true horrors of planets gone wrong. Mercury and Venus, the inner planets. Along with Earth and Mars, Mercury and Venus make up our inner solar system. Jupiter, Saturn, Uranus, and Neptune. These planets farthest from the Sun make up the gaseous outer worlds of the solar system. Over 4 billion years, the inner planets bound enough interstellar debris to become rock solid.
Why do we study planets? Why do we study astronomy at all? We someday need to go beyond the planet Earth if we expect to survive as a species for a very long time. And we need to know what's out there and what the nature of the universe is.
We're studying worlds where things are exotic, but the basic processes of physics and chemistry at work are really the same that we see here on Earth.
Millions of miles separate us from our rocky cousins. But a tour around Venus and Mercury reveals a common DNA.
We can go to Mercury and Venus and really look at these as places, as worlds with their own histories, and then contextualize our own planet's history.
Venus is the 6th largest planet in the solar system. At its closest, it is 26 million miles away from Earth. A year on Venus lasts 225 Earth days. And if you weighed 150 pounds on Earth, you'd weigh 136 on Venus. Venus. When the ancient Romans looked up, they were captivated by its commanding presence. They named the planet after their serene goddess of love and beauty.
It's such a beautiful presence in the sky. It seems obvious the connection there.
Venus has long been considered our sister planet because of its closeness in composition, gravity, density, and size.
Venus and Earth are almost twins in a lot of ways. They're almost the same size. Venus is slightly smaller than Earth. So if Earth was a regulation basketball, Venus is a soccer ball, slightly smaller. And Venus is the closest planet to Earth. So for a long time, it was thought of literally as a twin planet.
For ages, scientists thought this twin, like Earth, was a planet covered with deep oceans, lush rainforests, and had a climate that would give credibility to the notion that intelligent life could exist there.
Before the space age, people thought it might be very Earth-like on Venus. But the paradox is when we actually got to Venus and started exploring it, the conditions there are so different.
It turned out Venus was less of an exotic sister to Earth and more of an evil twin.
So here you have two very similar planets in their sort of bulk properties, but they've evolved to such different states. And that creates an interesting problem in understanding planetary evolution, a sort of controlled experiment. Take these two similar planets and let them go for 4 billion years, and then why do they end up so different?
First, some of the basic differences. Venus has been hit hard with meteors. One so strong that some scientists think it may have reversed the planet's rotation.
Venus has a very slow rotation, and it has what we call a retrograde rotation. So it spins backwards compared to the direction of spin of all the other planets.
Because of this retrograde rotation, the sun rises in the west and sets in the east. And the Venusian days are long ones. The amount of time from one sunrise to the next is about 8 Earth months. But the orbital pattern and long days aren't what make Venus so intolerable. In part, it's the wicked climate. With a surface temperature of 900 degrees Fahrenheit, Venus is the hottest planet in the solar system. Travelers there would have their trip cut short in no time.
It would take a matter of seconds, maybe 1 second before they were gone, roasted to death.
If you're an astronaut sitting on Venus without a spacesuit, then your skin's going to crisp up. You're going to cook just like a turkey in an oven, except much faster even.
The unforgiving heat wave is created by a process called the greenhouse effect, the identical process that keeps Earth's climate in check and teeming with life. But a closer look at Venus tells us how this common trait can be a cycle of life and a cycle of death. Today, our own temperature is on the rise, and scientists found the possible cause behind it up on Venus.
Global warming is a result of greenhouse gases that are growing and growing and growing, and therefore we're getting hotter and hotter. When we looked at Venus, we said, aha, here it is actually happening.
In the 1990s, after the Magellan spacecraft was launched, planetary watchdogs began turning to Venus to surmise just how bad it could get here on Earth.
Space exploration has told us a lot about the Earth and the environment it's in. And in fact, the greenhouse effect that everybody's talking about with global warming was actually discovered on Venus.
What they found out about Venus shed new light on how fragile Earth's greenhouse effect really is.
And Venus didn't always used to be this hot. We think that early in its history, it was more Earth-like on the surface, and it lost its oceans due to what we call a runaway greenhouse effect. So Venus is an example that certainly that global change can happen on a planet, and it's sort of a worst-case scenario. We don't have to turn Earth into Venus before we're in trouble. We just have to move a little bit in that direction. And we are moving in that direction. But the real value of studying Venus, it allows us to test our climate models.
Through computerized general circulation models, or GCMs, scientists were able to calculate temperature increases on Earth based on the amount of greenhouse gases on Venus. So just how does Venus's greenhouse effect work and make the planet so hot? This is Biosphere 2. Located along the foothills of Arizona's Santa Catalina Mountains, it was built by a group of researchers to explore the idea of colonizing other planets. It is the largest greenhouse on Earth.
Biosphere is a perfect example of a greenhouse because it's a big building with glass panes that let the sun in, and the air is really hot in here.
The solar rays that penetrate the glass panes cause the temperature inside to rise.
The air heats up, but then the air cannot escape, cannot move vertically into the atmosphere because of the walls.
The windows trap the heat, warm the building, and provide the plants and trees with a livable climate. On Venus, greenhouse gases don't exactly trap the sun's heat, but they greatly slow the rate at which it can escape.
The greenhouse effect on any planet is a situation where the surface temperature becomes hotter because of gases in the atmosphere that trap the heat while letting in the sunlight.
These same greenhouse gases that would prove to be fatal to us on Venus are essential to life on Earth.
Without the greenhouse effect, the average temperature would be far below freezing, the oceans would be totally or almost totally frozen, and it's not even clear if life would exist on the Earth.
We talked about how hot it was, but why is it so hot? The answer has to do with the atmospheric composition. It's almost all carbon dioxide there.
Carbon dioxide, or CO2, makes up 95% of the Venusian atmosphere, and that high volume of gas traps more heat.
That's going to give you a strong greenhouse effect, and that's going to make it really hot. And that's why it's so hot on Venus. It's an extreme example of global warming.
On Venus, volcanoes are the natural spring source for CO2 and other gases. It's a process atmospheric chemist Jeff Sutton studies on Earth at Hawaii's Kilauea volcano. Deep below the surface, atomic compounds ignite during volcanic activity to form CO2. The gas is born from the pressure created by the heat of molten rock, or magma.
It rises towards the surface and reaches the summit magma storage complex. The pressure is decreased on the magma. And the effect of that is to allow gases that are trapped under the very high pressure to be released and bubble out.
The Venusian surface would likely have cracks in the lava similar to these vents, where gases escape into the airstream.
Somewhere between 8,000 and 30,000 metric tons of carbon dioxide boil out of the magma chamber each day. And it amounts to something on the order of 3.5 to 5 million tons per year.
And that's just one volcano here on Earth. Venus has more active volcanoes, and that means more heat-bouncing gases.
So all the CO2 just builds up in the atmosphere on Venus, which just makes it hotter and hotter.
The 900-degree heat isn't the only trait that makes Earth's twin seem a menace. 30 miles above the scorching ground of Venus, there's havoc occurring on the planet that makes 900 degrees Fahrenheit feel like a cold front. Electrical mayhem, where split-second jolts can reach 50,000 degrees. Each spark of light contains 100 million volts of electricity. Lightning occurs on both Earth and Venus when electrical charges store up enough energy until they release a spark. Mears Oppenheim teaches planetary physics to students at Boston University. And researchers like him get in on the action at Boston's Museum of Science. In their caged lighting exhibit, 30-foot-high domes motor up to simulate how lightning is generated on Venus. And then, it's showtime.
So look at this. We're generating so many millions of volts on these domes that voltage has to escape. And it's actually ripping molecules in the air apart.
The air in the domes, like within the Venusian clouds, stirs up the electrical distribution of tiny atomic molecules.
So the ripped molecules make that light as they reassemble themselves, and that's what a lightning bolt is.
Cosmic particles from exploding stars way out in the galaxy trigger lightning. When these hit the atmosphere, they provide that spark.
These are particles that come from way out in the universe into the atmosphere and cause a shower of charged particles. And on Venus, you'd probably have real lightning to the extreme extent, contain enormous amounts of energy, and go for miles and miles.
On average, lightning hits the Earth more than 3.1 billion times a year. The number of times lightning hits the ground on Venus? 0. The atmospheric pressure on Venus is 90 times greater than on Earth because the weight of the atmosphere created by gases is heavier. This prevents Venusian lightning from hitting hard ground. Instead, it is restrained to the clouds.
There's just too much resistance in that very thick air for a lightning bolt to get through. It's much easier for lightning to discharge from cloud to cloud.
And besides appearance, there's little else that's Earth-like about Venusian clouds. In fact, the main ingredient that creates them is toxic enough to burn through human flesh. From Earth, you might be able to see Venus twinkle in the morning and evening skies like a star.
Definitely not a wallflower. It's so bright in our sky, not just because it's the closest planet to us, but because it's the most reflective planet. Because it turns out Venus is completely covered in these bright reflective clouds.
80% of the sun's light bounces off the clouds that blanket the planet. But even in the clouds, Venus, our so-called twin planet, manages to show an evil nature.
And we know that the clouds of Venus are made out of sulfuric acid, basically like battery acid. And that sulfuric acid is made by sulfur dioxide coming out of volcanoes on the surface.
Like its greenhouse cousin, carbon dioxide, or CO2, gas pressure pushes sulfur dioxide to the surface through volcanic vents. It's the same gas chemist Jeff Sutton monitors carefully at Hawaii's Kilauea volcano.
The gases, the sulfur dioxide in particular, is a noxious, toxic gas, and we wear gas masks to protect our lungs and our airway because sulfur dioxide combines with the moisture in your nose and throat and forms sulfuric acid.
Sulfuric acid is nasty stuff. You don't want to splash battery acid on you. You know, you're careful not to do that. It's basically the same stuff. So it would not be good to suddenly stick your hand into the Venus clouds.
So if a traveler to Venus could survive the acidic clouds, the lightning bolts, the toxic air, and the heat, just how would the Venusian surface look? Volcanologist Jeff Burns with the United States Geological Survey, or USGS, circles the globe to understand what drives volcanic activity on the inner planets. When Burns imagines the surface of Venus, he considers the dark, eerie wasteland of Kilauea's lava fields on the big island of Hawaii.
It's very instructive to be able to come here and study this volcano to compare it to volcanism that has occurred on the surface of Venus. We can actually come out here to the field and study things. We can actually take samples and look at them in detail.
Geologists expect the amount of volcanoes on Venus far outnumbers the 1,500 or so on Earth.
Some estimates range from 100,000 to over 1 million volcanic features on Venus.
With that many volcanoes, lava rock makes up 70% of the Venusian surface, just like it makes up much of Kilauea's terrain. The ground becomes solid when the lava cools into hard rock.
Having a rock on Earth is our best analog for trying to understand rocks on the other planets. Basaltic rocks are the most similar to the Venusian plains.
Basalt is the most common type of lava rock found on Venus and throughout the inner solar system. The minerals freeze into glass and small crystals, a total transformation from what lava looks like when it streams out of the volcano.
When lava is actively flowing across the surface, it's incandescent and typically looks red. Now, quickly it'll form a silvery sheen over the top of it, and then over a period of a few weeks will turn black, such as the lava we see around me here.
At 5 miles high, Mont Mons is the largest volcano on Venus. And it's left some tremendous lava channels in its wake, just like Kilauea did.
Now, as you can see, the structure, we have levees here on the sides, and then internal structures as well. This is similar, perhaps, to how large channels called canali formed on the surface of Venus. However, they formed at a much larger scale.
Large enough to create seemingly endless miles of canali across the Venusian landscape. Consistent in both width and depth, the canali are much longer on Venus than on Hawaii because of environmental conditions on the planet. The dense atmosphere and hot temperature slows the magma from cooling into solid rock. And with little wind and no rain to further cool the magma, lava can cut through the surface for months after an eruption before it hardens.
On Venus, if you did see layering, you would expect to see layer after layer of volcanic rock that would all be relatively black and basaltic in composition. You would probably see little bits of color due to potentially oxidized iron, which would look red. Typically, basaltic lava flows are glassy enough that, in fact, you would actually cut your hand. They can be extremely sharp. They tend to quench and form glass.
And then there are the skies. That heavy Venusian cloud cover diffuses most of the direct sunlight.
So it would be a lot darker on the surface of Venus during the day than it would be here on Earth. Also, because the light is scattered very efficiently, you tend to lose shadows. So everything is lit fairly consistently across the surface. And then additionally, because of the composition of the atmosphere, everything would tend to have more of an orangish tinge to it.
Besides canyons, jagged mountain ranges scrape the Venusian skies. The planet's highest peak is on Maxwell Monts.
Maxwell is about 35,000 feet high, which puts it at a healthy distance above Mount Everest or any mountain on Earth. Everest is something like 28,000 feet high. So it's definitely larger than anything on Earth.
Our sister planet seems to have outdone one of our 7 natural wonders. But how would the Venusian terrain measure up against another geologic feature, our canyons? The Grand Canyon, a great chasm eroded over 250 million years by the Colorado River.
When the Colorado Plateau was uplifted millions of years ago, it gave the water more energy to cut back through the canyon and wear away the rocks.
The vast canyons on Venus may have also been formed by erosion, but not by a river.
Volcanic systems can erode canyons by having fluid flow. If it's very fluid, not very viscous, materials can erode similar to water. And the Grand Canyon is only part of the Colorado River system, but even looking at the Colorado River system as a whole is not nearly as long as the longest channels on Venus.
Had the ancient Romans known about the volcanoes, acidic clouds, lightning bolts, toxic air, and that scorching heat, perhaps they may have named our evil twin planet after something other than their goddess of beauty and love.
There's irony there because, of course, the Greeks and Romans didn't know anything about the conditions on Venus. And then here we are a couple thousand years later, and we're actually exploring this place. And, well, it's not quite so nice according to our taste.
But how do the dangers found on our sister planet compare to the cosmic violence on Mercury? "48 million miles away from Earth, Mercury's dust-covered hills and empty plains stretch as far as the naked eye can see."
It's a colorless body. I mean, it does not have really any colors like you see on Mars or the Earth or even Venus for that matter.
Dr. Robert Strong with the University of Arizona's Lunar and Planetary Lab has been a chief authority on planetary geology for more than 35 years.
Mercury is the innermost planet, and it's quite different than anything else in the solar system.
At 36 million miles, Mercury is the closest planet to the Sun. The planet has no known moons. Mercury has no atmosphere. And it's a naked eye planet, visible on Earth during the twilight hours. With a diameter 60% smaller than Earth, Mercury is the solar system's scrawniest planet. Much too small to generate the strong gravitational field needed to retain an atmosphere.
Gravity depends upon the mass of the object, on the mass. So the larger the mass, the more the gravity. So on Mercury, the gravity is less on there.
Since the planet's gravity is so weak, if you weighed 150 pounds on Earth, you'd only weigh 57 pounds on Mercury. Planet size matters when it comes to the internal heat needed to sustain geologic activity.
The internal convection currents that drive geology stop, and in general, it just freezes up and there's no way to sustain that geological activity. And that happened to Mercury a long time ago, probably after less than 1 billion years of its life.
The days when the planet beat with a strong pulse that produced volcanic and tectonic Mercury quakes are long gone.
Is Mercury a dead planet? Depends on what you mean by dead. Is it internally active now? Probably not. It's probably not active at all.
It is essentially a dead planet and has been dead for about 4 billion years.
For a near lifeless planet, Mercury still has some movement. Named by the ancient Romans after the swift-footed messenger god, Mercury orbits the Sun in 88 Earth days, the fastest of any planet. But when it comes to the time it takes Mercury to spin on its own axis, the planet holds the record for being the slowest. Length of time, around 180 Earth days, about half a year. The Sun's gravitational force creates a tidal friction within Mercury, which slows down its speed as it spins on its axis. This means a year on Mercury is shorter than a day on the planet. And that sluggish rotation gives Mercury a somewhat peculiar weather forecast. For 6 months, the side exposed to the Sun reaches 800 degrees Fahrenheit. On the other side, the temperature drops to 300 degrees below zero.
It has a long time to heat up on the side facing the Sun and a long time to cool down on the other side. And that's why it has these huge temperature extremes.
Despite its close proximity to the Sun, Mercury is a bit of a black sheep in the planetary family. Its skies always seem like starry nights.
The skies would be black. The reason we have blue skies on the Earth is because of our atmosphere. Nitrogen scatters light preferentially in the blue, and so that's why the sky looks blue. Mercury doesn't have an atmosphere, so the sky would be black.
Legend holds that Mercury, the Roman god, invented the sport of boxing. This is one planet that's taken a lion's share in the ring. Mercury has had millions of meteors and asteroids explode on its surface because it doesn't have an atmosphere to protect it. Our atmosphere guards Earth from most impacts, like a force field. When a small object slams into it, usually at more than 10 times the speed of a bullet, the collision with air molecules vaporizes it into a gas.
The Earth is shielded from small impacting objects by this wonderful thing that we call the atmosphere. And for small objects, weak objects, they will be completely destroyed by those forces long before they get here to the geologic surface of our planet.
On Mercury, without that atmosphere, the asteroids and meteors smack down at full throttle. This makes Mercury the most heavily cratered planet in the solar system.
You cannot take a step on Mercury without encountering an impact crater.
Back in 1974, the Mariner 10 space probe mapped half the planet's surface, including the largest crater ever surveyed in the solar system.
The most prominent feature is a feature called the Caloris Basin, which is a very large impact crater that is about maybe 900 miles in diameter.
900 miles in diameter. That's a couple hundred miles broader than the entire state of Texas. Researchers speculate the iron meteorite that made that impact stretched for more than 60 miles before it crashed into the surface. Moments after impact, seismic waves converged at the antipodal point, the spot on the exact opposite side of the planet.
The seismic waves, the shock waves from this thing traveled, and they've concentrated simultaneously around the other side of the planet and literally shook apart the surface.
The seismic turbulence jumbled up the crust and twisted the terrain into unusual rock formations.
There's all this weird terrain. In fact, the technical term is weird terrain. Because you look at it and it's just weird. It's jumbled up and hilly and doesn't make any sense according to most geological activities. It's just very rough and looks as though somebody kind of scooped up the surface and just kind of dropped it down.
Pre-existing craters suddenly became crude hills, some 6 miles wide and a mile high.
In fact, the amount of surface elevation could have been on the order of a kilometer or two in just a few seconds. It would have been horrendous.
Scientists have no way of knowing exactly when the Caloris impact happened, but they can surmise one thing. If an asteroid the same size crashed into the Earth, the impact would be catastrophic and wipe out human civilization. Countless meteor and asteroid impacts have left Mercury scarred with dents and crater rings. Today, the planet looks beaten, a terrestrial corpse. Like Mercury, Earth's surface is vulnerable to bombardment. And Arizona's meteor crater is one of our most preserved and Mercurian craters. The desert basin has given geologists a better understanding of what happens when a meteor strikes Mercury's surface. Upon impact, energy from the shock wave rips through the surface and moves tons of rock upward to shape the crater.
And that flow of rock excavated this bowl-shaped cavity and deposited debris on the landscape for kilometers around. Same energy swept up the crater walls and caused these flat-laying layers of rock behind me to actually be uplifted. And the rock, under the influence of shock, wasn't behaving brittly like rock does, but more like taffy. This is one of the hallmarks of impact craters, not only here at Meteor Crater, but anywhere in the solar system.
But imagine if the mighty object that formed Mercury's Caloris Basin crashed down on the site of Meteor Crater.
It would be a massive explosion with chunks of molten material flying around the Earth ballistically, re-entering the Earth's atmosphere and causing just massive meteor showers everywhere.
For nearly 7,500 miles, the shock wave would rip up the soil and stir up tsunamis with 2,000-foot waves.
massive tsunamis propagate around the Earth and inundate much of the world's coastlines.
It would flatten Las Vegas, Nevada, the cities of Salt Lake City, Utah, San Francisco, California, and Los Angeles would vanish in a split second.
Shock waves from the impact would propagate through the solid Earth thousands of miles from the site of an impact like that.
Those seismic waves would converge at the impact's antipodal point, off the coastline of Africa's Madagascar, at the bottom of the Indian Ocean. Suddenly, a mountain range would explode through the ocean floor and crash up to form that weird Mercurian terrain.
Like an unbelievable earthquake, probably everywhere on Earth for an object that large.
Meteor crater would be a nick in the surface compared to the Mercurian gash left behind from a Calorus-type impact. The gouge would consume a quarter of the continental United States.
An object that size would eliminate a large portion of the west coast of the U.S. if it fell, say, on Arizona. It would literally change the coastline in an instant.
Back on Mercury, those craters give it an iconic stature in the solar system, and some of these pockmarks harbor mysteries. When the radar at Puerto Rico's Arecibo Observatory honed in on Mercury's poles, it picked up something that left researchers befuddled.
Ice, of all things. One of the hottest bodies in the solar system, and it has ice in the poles. And the reason it has ice there is because Mercury is a heavily cratered surface. And so craters in the polar regions, the inside of them are constantly in shadow.
That's because Mercury is vertical relative to the plane of its orbit. So some crater floors never receive light or heat from the sun. But with no obvious water source on the planet, that begs the question, how did the ice get there? Scientists believe the mystery ice could have come from a comet. Comprised of rock, dust, gases, and ice, comets come from the outer reaches of the solar system, where the temperatures are much colder.
Could this ice just be on the bottom of permanently shaded craters? Or could it be ice that's sort of covered up by a layer of dust, which is shielding it from sunlight? We really don't know.
Besides these comet collisions, there is yet another type of crater on the planet, and they weren't formed by anything that fell from the sky. Instead, an Earth-like force of nature created these holes, and it generated deep from within the planet's core. Mercury. A closer look at its terrain by scientists reveals that some of its craters could have been formed from something other than asteroids, comets, and meteors.
We do understand that the dominant geologic process that affected Mercury, at least Mercury's surface, is impact cratering. The second most important geologic process to affect Mercury is volcanism.
Although we haven't seen any definite evidence of volcanoes on Mercury, we do expect that there have been volcanic eruptions in the past.
This remote cow pasture, a 3 hours drive north of Phoenix, might contain a telling link to Mercury's volcanic history. The cratered hills are extinct cinder cone volcanoes, and geologists suspect similar ones can be found on Mercury.
This is a cinder cone. You can see behind me there's a large crater in the center, which is typical of cinder cones.
These volcanoes do have their differences with Mercury's cinder cones.
Because Mercury has less gravity, we would expect the cinder cones that form to be much wider and much flatter.
All volcanoes erupt when the pressure from the magma, or molten rock inside, is greater than the strength of the rock containing it. Pressure increases for two reasons: too much magma and too much gas. And when pressure increases in a volcano, it usually has one place to go.
Lava comes up to the surface and erupts explosively. You have a vent area and you have what's called a fire fountain.
If the pressure is great enough, its force can spew lava higher than 100 feet on Earth. But on Mercury, with such low gravity, the fountain could eject lava 30 stories high. While these cinder cones in Arizona may illustrate our shared volcanic heritage with Mercury, to witness an eruption there firsthand and watch the cinder cones form would be a whole other experience. First, without an atmosphere, a plume of ash and smoke and debris wouldn't billow across the landscape.
That material would go into essentially a vacuum of space because Mercury doesn't have an atmosphere, so that material would break up much more.
Also on Mercury, you wouldn't be able to hear the loud eruption.
Since Mercury has no atmosphere, there's no way of transmitting sound. So if you were on Mercury and playing a guitar or a ukulele or a piano, you would not hear anything because there is no atmosphere to transmit that sound. So it would be just complete silence.
Back in 1974, Mariner 10 surveyed only 45% of Mercury's surface on a flyby mission. 30 years later, NASA launched the Messenger spacecraft. The satellite will map the entire planet and transmit data to eager scientists with a deluge of unanswered questions.
I want to see the other side. I don't know what's over there, and that's been bugging me for 35 years. Is it like the side we saw, or is there something very unusual and different?
But even with resources being earmarked for future exploration of this rumpled dwarf in the solar system, exactly how different or similar we really are may be left up in the air. Despite the harsh conditions on Mercury and on Venus, a close look around our own backyards reveals the good, the bad, and the ugly of the inner planets.
The universe is this vast, vast thing, and here we are sitting on this little pinprick. I mean, we are not isolated.
We see things that happen on these other planets for tremendous climatic changes in the past that have happened in a very short period of time and changed that. And that can happen on the Earth.
Ultimately, it enriches our knowledge of who we are and how unique and how rare an environment like ours and even creatures like us might be in the universe.
And that evolution, that exploration, that turning the corner, that discovery of new ideas is what we're all about. There's a bright future.